Let's go ahead and get started. First off, it's a real honor and pleasure to be here to speak with you today. I want to speak with you about my favorite topic, architecture of data. When data architecture started, it was very simple. It was simply a matter of taking a few elements of data, putting them into a file, and that was what data architecture was like. But in today's world, we find that the world of data architecture has evolved immensely for a lot of reasons. So let's talk about this evolution. In the very beginning, we had very simple forms of data. We had punch cards, we had paper tapes, and then we progressed to master files, sequentially taped files, then to disk storage, then we started to build online applications. And online applications turned out to be very, very popular. We run banking systems, we run airline reservation systems, we run a lot of the world on transaction processing systems. And because they were so popular, we started to see these systems start to proliferate. And now my computer doesn't work. And soon we started to see a proliferation that looked something like this. We had extract programs, we had applications, we had databases, we had a whole world that looks like this. And this led us to something that we call spiderweb systems. Now, this diagram here is a real diagram. This is from a company that I did some work with a while back, and each one of the little boxes represents an application, and each application has anywhere from 5 to 100 people in it. So this represents about the work of 10,000 people. And so how would you like to try to use this to make management decisions with? And the answer is, it was a maze that nobody could figure out where anything was or what anything meant. And so we find that the same element of data has a different value in different places. In one place it's 200, another place 5,000, another place 750, another place 36. And how are you to make any valid, intelligent business decision when you don't know what the data is? And so this, by the way, is called the disintegrity of data. This means that you've got data, it's accessible, you just can't believe it. And believable data is at the heart of making business decisions. And so from an architectural perspective, now let me talk just a second about let me go back and talk about the spiderweb environment. What happens when you add programmers and technology and systems to this environment here? What happens is things get worse, not better. They really and truly do. That adding more technology, more hardware, more programmers, more consultants does not make the problem go away. You need a different kind of solution. And so the solution that we came up with was an architectural solution. The architectural solution was something called a data warehouse. And the idea behind a data warehouse was that a data warehouse separated the transaction processing operational systems from the analytical systems of the corporation. And by making this separation, we were able to start to address this problem of the spider web environment. By the way, in case you're interested, this is sometimes called the spider web environment. And I hope you can see why it's called a spider web environment, because it kind of looks like one. So we discovered that what we needed was an architectural solution to this problem. We needed something called a data warehouse. Now, the definition of a data warehouse was created many years ago, about a quarter of a century ago, And the interesting thing is the definition of what a data warehouse is has not changed to this day. So what is this thing called a data warehouse? It's something that's subject-oriented, integrated, non-volatile, time-variant collection of data in support of management's decisions. That's what a data warehouse is. Now, in today's world, we have different implementations. We can implement a data warehouse on the cloud. We can implement a data warehouse on Oracle. We can implement data warehouse on a variety of technologies. So the platform and the technologies have changed, but the whole notion of what a data warehouse is hasn't changed. Now, in order to get data from these applications and put them into a form of a data warehouse, we needed to have programs that were written. And these were transformation programs. These transformation programs took the application data and turned it into a data warehouse. And we soon discovered that these transformation programs were very tedious to write. And besides that, once you've written one, you've essentially written all of them that you're ever going to want to write. So there was technology that was created called ETL, Extract, Transform, Load Technology. And the Extract, Transform, Load Technology is technology that allows us to take application data and turn it into a data warehouse. And so let's talk just for a second about these transformations. What do we mean by a transformation? Well, in one application, we have a person's gender as M and F. In another application, we have gender as male and female. In another application, gender is a 0 and a 1. And each application has its own interpretation of what data should be. But when we go to a data warehouse, we need to have a unified corporate understanding of data. We need to decide whether gender is male or female, M or F, or 1 and 0. And it doesn't really matter which one we choose, but we've got to choose a single way of representing the data for our corporation in the data warehouse. So we then found that once we built the data warehouse, people then asked the question, can my user go directly to the data warehouse and start to use it? And the answer is yes. Yes, you can have direct usage of a data warehouse from your user community. But people quickly discovered that they needed to take the detailed atomic level data, which is what's in the data warehouse, take that data and turn it into data that's applicable to the different departments of the world. We needed to have a financial data mart, a sales data mart, a marketing data mart, a management data mart, because sales looks at data one way, finance looks at data another way, marketing looks at the same data another way, and each of them need their own things called a data mart. And so we found then that in order to accommodate the data mart, and this is part of the architectural evolution that I'm describing to you here, in terms of the data mart, the dimensional model by Ralph Kimball fit very well, using star schemas and fact tables, and the relational model fit very well with the data warehouse. So from an architectural evolution, we went from applications through ETL to a data warehouse into data marts. And so this then is the higher level architectural perspective of what most people construe to be a data warehouse environment. Now, there's something that's kind of misleading here, and we're going to get into this into my presentation tomorrow, but It turns out that when people build these things called data warehouse, they're really looking at structured data. And there's nothing wrong with structured data. We need structured data to run our businesses with. However, there's a lot of other kind of data that's out there in the world that's important data as well. There's textual data, there's what's called analog or IoT data, and those kinds of data don't fit well in a data warehouse environment. So the data warehouse grew in popularity. It's kind of interesting. I don't know if you know much about the history of data warehouse, but in the early days, data warehouse was routinely rejected by the technicians of the world. The reason why data warehouse was successful was because of people in marketing. People in marketing had a real thirst for the kinds of data provided by a data warehouse, whereas initially people in technology rejected the data warehouse. Back in the early days, a database was thought to be a single source of data for all processing. And when data warehouse came along, data warehouse said, no, you have to separate these kinds of data from each other. And the theoreticians and academics of the world found the thought to be very threatening. And so they rejected data warehouse. But the people in marketing, the people in finance, the people in sales, all of them said, wow, I want and need this thing called a data warehouse. If it hadn't have been for marketing and sales and finance, we never would have had success with data warehouse. So we find then that the operational application needs are served off over in one world, and the analytical needs of the organization are serviced in another world as well. And data warehouse serves the purpose of servicing the analytical portion of the world. Now, one of the things that people found is that as time passes, the volume of data in the data warehouse starts to expand beyond anything anybody has ever seen. And there's a lot of reasons for that. The main reason for that is the fact that data warehouses are very convenient for containing historical information. Data warehouses can contain 5 to 10 years worth of information. Whereas your operational systems, your transaction processing systems, want to minimize the amount of data that are in those systems. You don't want to keep 5 to 10 years worth of data in a transaction processing system. So it was a natural thing to find that data simply expanded when you started to have a data warehouse. And furthermore, the number of users started to expand as well. And so looking into the future, there's something out there that is a relationship to a data warehouse. The next version of data warehousing is something called the data vault architecture. If you haven't looked into data vault architecture, I suggest that you do so. From a technology standpoint, the platforms that we can put a data warehouse on have expanded greatly. Once upon a time, you only put a data warehouse in your systems that you have in your corporation. Today, it's very convenient to put a data warehouse on the cloud. And you can still put it into your own organization. From a standpoint of who's using the data warehouse, management and analytical processing are the people that are using the data warehouse. There's lots and lots of different kinds of applications that are out there that are all serviced by the data warehouse. Now I'd like to get into an interesting topic. You say, gee, Bill, thanks for telling me all of this. This is really good, but you're talking this whole talk about structured data. And is that what I've been talking about? Yes, that's what I've been talking about. And you say, wait a minute, if I look into my corporation, don't I find a lot more than structured data? Don't I find a lot of this stuff called unstructured data? In fact, in most corporations, structured data takes up this much space and unstructured data takes up this much space. So it's kind of interesting because we've spent all of this time looking at a small minority of our data. And so what do we find when we look at our unstructured data? What we find is we find things like email, call center conversations, contracts, medical records. A whole world of information is not being covered by what we construe as data warehouse today. So I want you to be aware of that. And you say, gee, isn't something wrong with this picture? That we in our corporation are looking at all of this structured data. And by the way, there's nothing wrong with looking at structured data because it's important data and it's got a lot of business value. But there's another whole world that's out there of unstructured textual data that is not being looked at. And that is something that, come on, computer. My computer has now decided that, okay, there we go. That once we start to include unstructured data along with our structured data in our analytical processing, we find that our end users start to become a very, very happy people. And so what does the future look like? The future looks like a combination of information for analytical processing for the structured world and the unstructured world. There's something out there called a data lakehouse that I'll be talking about tomorrow that talks about how it is that this world comes into play. Okay, I have time for questions. Anybody have some questions? No questions? Yes, sir. I'm going to have to come over to you and listen to you because, yes, I can barely hear you, yes. Okay. Yes. Yeah. Okay. Let me try to answer your question. When Ralph Kimball was talking about his work, he was answering a different question than I was answering. Ralph Kimball was talking about how fast can you get results from an application. That's what Ralph Kimball was talking about. I was not talking about that. I was talking about how do you get believable results from an application. And the questions sound the same, but they're not the same thing at all. And if you want speed and fast and get something out there quickly, then the Kimball approach is absolutely what you want to do. If, on the other hand, you want believable results, if you want to do that dirty work of integration of data, I liken it to planting tomatoes in the springtime. How do you plant tomatoes in the springtime? You get your hands dirty. I don't know anybody on this earth that can plant tomatoes in the springtime without getting their hands dirty. And that's what's required when you have integration. With integrating data is complex, slow, fraught with errors, all of the things that we don't like. And yet that's what it takes to get that data into a corporate format. So when you talk about the Kimball model versus the Inmon model, Ralph Kimball, was answering a different question than what I was trying to answer. And I wish that Ralph, in his books, hadn't called things a data warehouse, because he was talking about a data mart. But he, for whatever reason, chose to call it a data warehouse and caused great confusion in the world. But let me tell you what happens when you try to use the Kimball model for analytical processing. In the first 6 months, you're going to be happy people. You get quick results. In the next 6 months, you start to notice something. You start to notice all of these data marts, and your users are asking which data mart has the right answer. And a year from now, you're going to have this mountain of data marts, each of which has a different answer for what you're looking for. And if that's the result of using the Kimball approach. And now, have I ever said, not even from day one, is the Inmon approach to data architecture easy and fast? Never have I said. I know that integrating data is like planting tomatoes. You gotta get your hands dirty. And it's a slow, complex, ugly process. But that's what it takes to get believable data. I hope that answers the question. Yeah. Okay, any more questions? Yes, sir.
So, I guess I'm wondering if you agree with what part of implementing a data warehouse is the hardest part? Is it actually the technology or processes?
Oh, the hardest part of the data warehouse has always been integrating the data. Going back into those legacy applications. But what's wrong with legacy applications? First off, there are a lot of different technologies, number one. Number two, oftentimes they're not documented. Number three, even when they are documented, you still are wondering what the heck does this mean and how is it calculated? So going back into those old legacy applications and trying to understand the data, that's the hard part of a data warehouse. And it's been that way from day one, and it's that way today, and it's going to be that way tomorrow.
And what kind of organizational structures or like team setups or whatever you want to call it would you recommend to optimize for these things in your experience? What has worked? Should it be a central team doing all the transformations, or who should do the transformation?
Let me answer your question indirectly. I can give you a direct answer, but how do you have the organizational will to build a data warehouse? And you do it through pain. That when an organization, you're laughing. What are you laughing at? I mean, that's the truth. That when an organization feels pain, then they'll understand the value. You show me an organization that doesn't understand pain, and they won't have the motivation. They'll take the easy way. We'll just throw some Kimball stuff out there and whatever. So the deciding factor in a proper implementation of a data warehouse is pain. And you show me a lot of pain, I'll show you somebody that understands what we've talked about here. Now that's not. You asked a little bit different question, but when I go into and consult with organizations, let me tell you something. If there isn't pain, you ain't going to be building a data warehouse. Pain is your best friend.
But once they have the pain, how should they get around doing it?
Okay.
I guess that's more in my.
Now we get into the role of a person we call the data architect. And what you need is a good data architect, a strong data architect. Let me tell you a little story, a true story I might add. Once upon a time, I was a consultant to a bank, and this bank had all of these consultants, people running around like chickens with their heads cut off, just doing this and that and the other. And the manager said, "Wait a minute, we're not getting any results here." And so they brought me in to give technical advice. But they had this woman, whose name I forget right now, but I can see her face. This woman, and said, "We want you to get people's attention, and we want you to run this project. And what we want you to do is pick out 5 people randomly and go fire them, and say, you're fired, you're fired, you're fired." And he says, once you do that, people will start to pay attention, and people will take you seriously. And by God, that worked. And again, you're laughing, but that's a true story. And that's what it took to get the organization online. I'll tell you another story. There was a guy at Hewlett-Packard named Mark Hurd. I don't know if you've heard of him. He was president of Teradata. Then he went over to HP. Then he went to Oracle. But Mark Hurd, when he went to HP, I don't know if you know about HP, but HP is like 17 different businesses. And Mark Hurd, and each business had their own individual accounting system, which meant that the accountants at the end of the quarter had a nightmare on their hands. So Mark Hurd went in and he said, "Okay, we're going to use," and I remember which one it was, "this accounting system." And he says, "This is the one, and by this date, you're going to be on the system. If you don't like this management decision, we suggest you find a job elsewhere." And guess what? Hewlett-Packard unified there. But that's what it takes. I don't like to talk about an iron hand. I really don't like to talk about it. But sometimes you got to stand up and have an iron hand into what you're doing. But pain is behind. If you don't find pain, you're not going to build a data warehouse.
Thank you.
Good questions.